I welcome you all to the session of engine system and performance, and the topic of our today's discussion is the actuators in engine control unit or engine control system. So, in our last few classes we have talked about or we have discussed about the sensors, the need of a sensor in the electronic control unit, then input to the sensor, output from the sensor, and then we have talked about 4 different types of important sensors for modern engines. We have also discussed about their operational procedure, hardwares, and then a particular type of sensor, why that sensor is needed for the safety of the engine as well as efficient operation of the engine. So, in continuation of that, we also should know about another important element for the electronic control unit or engine management system is the actuator. Actuator or actuators are also important for the electronic control unit of modern engines. What we know from our understanding of sensor is that the output from the sensor is essentially an electrical signal. Now, that signal should be given to the electronic control unit, and if we try to recall, for example, if we know that the vacuum in the intake manifold is more, that would be sensed by the manifold absolute pressure sensor, and eventually that information should go to the ECU. Receiving that input, ECU, the computer of ECU will give some feedback to the fuel injectors to supply additional amount of fuel so as to have a balance of the air fuel ratio. Now, the question is that information should go to the fuel injection system. That fuel injection system now should be in a position to supply additional amount of fuel, and that means if it is a signal received from the manifold air pressure sensor, that signal will be received by the ECU, and ECU will eventually give some feedback to the fuel injectors so as to increase the opening area of the fuel needle which is there in the fuel injector system, so as to increase the path or pathway of flow of fuel, and additional amount of fuel can be discharged. Now, all these things are done by the actuators. So, essentially what we can understand now, actuators are like sensors, are important elements for the electronic control unit. Then from our understanding, what we can see that input to the actuators should be an electric signal, and then what should be the output? We can understand that essentially if it is the example that we took today, for that particular case, if we need to really increase the area or fuel discharging area, certainly fuel needle needle of the fuel injector has to have some sort of displacement. So, mechanical output. So, actuators are important elements for the electronic control unit for the control of air fuel ratio, ignition, and EGR, that is exhaust gas recirculation. So, let me write here, if we write here that these are important elements for ECU or engine management system. To control what? Air fuel ratio, ignition, and EGR. EGR is exhaust gas recirculation. So, then as you can see that output from the actuators are mechanical or thermal output. Essentially, input to the actuators are electrical signal. So, receiving electrical signals or electrical signal, actuators are responsible to have or to produce some output which are mechanical or thermal output. Typically, examples of actuators are, so examples are electric motor. We shall discuss today about this stepper motor. Number 2 is, which is very important, that is solenoids. Number 3 is piezoelectric forcing, piezoelectric forcing generators. So, these are the typical actuators. We shall discuss all these today, their hardware structure, and then we will see how does an actuator control air fuel ratio, ignition, and as well as easier. So, let us first look at the schematic depiction that we can see in this schematic is, this is construction and principle of operation of a solenoid. Why solenoid we had taken first for our discussion, because out of these 3 different types that we have listed down over here, electric motors, solenoids and piezoelectric forcing generators. Out of these 3, solenoids are mostly used. This particular type is the most popular type because of simple design as well as less expensive. I can't say that it is inexpensive, but as compared to this another 2 different types, solenoids are simple in their structure and design, as well as operation is not expensive, less expensive. So, this is the schematic depiction of a solenoid. What we can see from the schematic depiction, say if we give name, this is A and this is B. So, this is the let us first discuss about the hardware, and then we shall discuss about the operational procedure. So, what we can see, if we look at the schematic A, then we can see solenoid is essentially but solenoid has a few components. It consists of a steel frame. So, you can see this is a steel frame which is ferromagnetic. So, the you can see that this is steel frame. So, this is steel frame which is ferromagnetic, that is also having another steel material. So, steel solenoid consists of a steel frame which is ferromagnetic, that contains another steel element which is known as armature, and another connecting rod that we can see, and the spring. So, these are the very important elements for this. Let me repeat once again. Solenoid consists of a hollow steel structure which is ferromagnetic in nature that is shown over this hollow structure with black colored having black colored outline, contains another steel element which is known as armature and connecting rod or rod and the spring. So, these four essentially it is having a hollow steel structure which is ferromagnetic. Inside this hollow structure we have another steel element that is armature. It has a rod and spring. These two are basically these two are mechanical stop. These are mechanical stops. Now, what you can see, now let us discuss about its operational procedure. Since the steel structure, hollow steel structure is ferromagnetic in nature, the wire is wound over the steel structure. So, let me show here. So, you know that wire is wound over the steel structure which is ferromagnetic in nature. It contains another steel element that is armature. When we allow current to flow through this wire, then it forms a strong electromagnet, right. And the moment when we pass current through this wire, which is there, which what we can see from the schematic, a strong electromagnetism is formed, and that electromagnetic force will try to push the spring and it will have some downward movement that we can see from the schematic depiction B. Let me repeat once again. As I said you that here that a coil of wound around the steel frame. This is a steel frame, a coil is wound over the steel frame, right, or a coil is wound around the steel frame, and this allows this entire part to become a strong electromagnet, right. So, rather powerful electromagnet. When we pass electric current through this wire, electrical force will be generated. That force will try to create a or that force will enforce the spring to be compressed and causing that rod or this entire element to come down. So, downward movement and the force that we can see. So, this is creating a downward movement. So, basically if we now discharge the current, if we switch off the current through this coil, then again there will be no force, electromagnetic force. Since it is spring loaded, so the natural tendency of that particular element or the spring will try to push it off again or to restore its original position. So, this way that if we give some electrical signal, electrical voltage, that is from the sensor, that will now create some additional forcing through the formation of powerful electromagnet, and that force will try to compress the spring, causing a downward movement of this entire setup. The moment we kind of switch off, or if we do not supply any current through the wire, since it is already spring loaded, natural tendency of the spring will be to again uncompressed, to get uncompressed, and the structure in steel frame along with armature will try to come back to its original position. So, this way we really can control the movement of this assembly. If we now somehow connect any mechanism, so what we can see from the here, let me write here, that will help you to understand. So, that so I can write one by one. A coil is wound around the steel frame forming a powerful electromagnet, right. Then as I told you that that armature and rod are connected. So, if we go back to this armature and rod, these two things are connected to this housing using the spring, through the spring and stay at equilibrium point. So, this armature and connecting rod, these two parts are connected to the housing through the spring and stay at equilibrium condition when there is no current, right. So, let me write here the armature and rod are connected to the housing through the spring and stay at equilibrium when there is no current to flow. Current flow through the coil. Okay. Now, when there is a current flow, so when the current flows, when current flows through the coil, right, a magnetic force powerful electromagnet is formed. So, then a magnetic force, rather electromagnetic force will be generated that pulls or that will pull the armature downward. That is what we have already discussed. Now, let me write on the important thing. So, when there is, so if we allow current to flow through the coil, because of this electromagnetism or strong electromagnetic force will develop or will be generated, and that force will pull the armature downward, that we can see from the schematic depiction shown in here, that is in B. So, if we now discharge the current, rather if we switch off the current flow through the coil, then since it is spring loaded, natural tendency of the spring, so spring force will try to restore the original position of the armature, that is what is the complete cycle. So, let me write again, right. So, when current is cut off, right, the spring force pushes, the spring force will push off the armature, and the rod back to their initial position. So, in this way we can have one kind of abrupt motion of this rod and armature. So, the armature will come down pushing the rod further downward, and then if we switch off the current, then it will again come back to its original position. That means, we can have an abrupt motion of this entire assembly, that is rod and armature. So, what we can see, this abrupt movement, of the movable element of the movable element is essentially in the form of a mechanical switching action such that the solenoid tends to be either in rest, solenoid tends to be either in rest or against the mechanical stop. So, if we go back to the previous slide, so these are again mechanical stop. So, these are again mechanical stop. So, mechanical stop. This is also mechanical stop. Okay. So, if armature gets or armature, when the armature is coming down, it will stop over here, and if we switch off the current, then again it will come back to its original position. So, this abrupt motion is as if the abrupt motion is in the form of mechanical switching between these two locations of the armature. One is the its equilibrium location, that is when there is no force. So, it will be in equilibrium condition, but when there is a force acting on the armature, it would be under compressed condition and it will rest on the mechanical stop. So, this is what we can understand. As I told you, now if we somehow connect any mechanism to this rod and that mechanism also be having corresponding movement as the armature is moving between these two locations. So, what you can see, the armature is having an abrupt movement between two locations. One is, that is what we have discussed here, that rest, that is equilibrium condition when there is no forcing at all, and when there is a force acting on the armature, it will come down and it will rest on the stop. If we now have any mechanism connected to the rod, that mechanism also will be having a motion in tune with the movement of the armature and rod. And if that mechanism is now connected to the valve of the fuel injector, if that mechanism is connected to the valve of exhaust gas recirculation, then by tuning the switch of the solenoid, either allowing the current to flow through the coil which is there over around the steel frame, we can control the movement of the armature, we can control the movement of the mechanism that is connected to the rod. In a way, we can control the movement of the valve and we can control the fuel injection time and the exhaust gas recirculation valve. So, this is all about the solenoid what we have discussed today. As I said, that it is simple in design and structure, together with inexpensive, not I can't say inexpensive, rather less expensive aspect, or that is very important for this particular type of solenoid actuator. Because of these two important aspects, solenoid is most popular in the modern engines for controlling the valves. So, with this let us now go to discuss about another important type of actuators, that is piezoelectric actuator. As we have mentioned in one of the slides before, that piezoelectric forcing generators, that means we can have some forcing to be or some force to be generated by virtue of expansion of piezo crystals. So, piezoelectric materials, if we allow current to flow through the piezo crystals or piezoelectric materials, they they will expand, and if we now again discharge, or if the piezo crystals discharge current, then again it will come back to its original position. So, by expanding piezo crystals and again bringing them in their original position, we can have some control, and if we can connect some another mechanism to the piezo crystals, then in tune with the movement or expansion and compression of the piezo crystals, that mechanism also will be having some linear motion. So, in the first case, that solenoids, solenoid is basically a type of actuator wherein electrical signal is getting converted to the linear motion. Okay. So, I forgot to write that solenoid, solenoid or solenoids convert electrical energy to linear motion. That is very important. So, now let us look into this particular type, that is piezoelectric actuator. Let me write here a few important aspects, then we will discuss. As I said you, this is the hardware, we can see the constructional feature of this particular type of actuator. Let me write a few important characters or characteristics of this particular type, then we shall discuss. So, that this particular type is becoming more popular in the fuel injection system. If we probably by this time already have studied internal combustion engine course, fuel injection system is basically the one multinational company is their boss. So, because of the series production of Bosch's Mondal system way back in 2003, this type of actuators became very popular for the fuel injectors. So, let me write here that Bosch's third generation of with the introduction of Bosch's third generation Mondal system, I should write here. Mondal system, right? Piezo electric system, with the introduction of Bosch's third generation of Mondal system, I should erase now, that is in 2003, way back in 2003, piezoelectrical system became more popular in fuel injection system, right. So, from the name itself you can understand that this particular type of actuator uses piezo crystals. So, that what you can see from this particular that schematic depiction, piezo crystals are stacked vertically to form this cylindrical shaped piezo actuator. Piezo crystals are stacked vertically to form this type of or cylindrical shaped piezo actuators. The piezo crystals have a specific property. Let me write that property, then I will come back again. So, that so piezo crystal have an important property or has an important property of expanding in an electric field. In an electric field. So, that is very important, and piezoelectric actuators work on this principle. Piezo crystals, if we go back to the previous slide, as I said, piezo crystals having certain amount of thickness, these crystals are stacked together to form this vertical type or cylindrical, they are stacked vertically, they are stacked together vertically to form this cylindrical shape piezoelectric actuators, and these piezo crystals have a very important property, that is they expand in an electric field. Now, let us discuss about another important aspect of this particular type of actuators. So, that these as I said you, this piezo electric actuators work by passing electrical current through piezo crystals, or through a stack of piezo crystal, through a piezo crystals or a stack of piezo crystals. Right, causing them to expand. Next is, as the current or as the crystal, piezo crystal discharge current, it contracts, or as the piezo crystals, or they contract to the original size. So, these two are very important. As I said you, that piezo crystals have an important property, that when an electric current is allowed to pass through those crystals, they expand. So, that means they have an important property of expanding an electric field. From the schematic depiction that we have discussed in the previous class, that a few piezo crystals are stacked together vertically to form this type of actuator. If we now allow electric current to pass through these crystals, they will expand, causing them to have some linear kind of, is the piezo crystals are expanding. So, entire stack will be having some linear movement, and when crystals discharge current, all these crystals will return to their original size. So, that means if we now go back to the previous slide, if you can see this needle, so this needle is now connected to these piezo crystals. A few crystals are stacked vertically to form this actuator. If we allow now current to flow, they will expand, they will create, as they are expanding, they will create some downward forcing to this needle, and the needle will come down. If we if the needle come down, then you can see that this area through which fuel will flow from this kind of nozzle, pressurized fuel from the nozzle. So, fuel is coming from the nozzle, from the fuel tank, and it is getting stored over here. Now, if that nozzle is, that needle is always getting seated, the nozzle is always remaining seated over here. If we somehow can create some forcing on the needle, and if the needle is having downward movement, then we can control the opening area through which fuel will flow from this device into the fuel into the engine cylinder. So, that means by passing the current or tuning the magnitude of current, we can have the linear movement of the needle as the crystals are expanding. So, this expansion will create some thrust or force on the needle will have downward movement, which in turn will allow the opening area through which fuel will flow, and we can control the fuel to be introduced in the engine cylinder. So, this is how this particular system works. Now, typically for any fuel injected for any engine, that fuel flow characteristics should be rectangular flow type. So, let me write here. Now question is, you should know that okay fine, the piezo that the piezo crystals are having almost negligible mass. So, because of this low inertia, typical time to open and close this needle. So, that means to have piezo crystals are having almost massless, I should say, negligible mass, inertia is less. So, by passing current, if the crystals are having significant or high mass, then what will happen that though we will be allowing current to flow, that inertia will not allow them to expand, and that inertia will not allow the needle to come down. So, because of this negligible mass of the crystal, inertia is less. Typically the time of opening and closing the needle is 250 millisecond, of the order of 250 millisecond. And as I said you, almost kind of all fuel, all engine injection system is or need a particular type of characteristics. So, let me write these 2 points and then I will discuss. So, as I said you that piezo crystals are having negligible masses, and thus the inertial effect due to the involved masses, is very less, okay, very less. It is because of this, less than 250 microsecond is needed to switch from the closed position of the needle to its open state, right. As I said you that fueling characteristic of all nozzle or modern engine need a requirement, a basic requirement, which is rectangular flow filling. So, as I am telling, let me write that most engine applications need a specific requirement or specific fueling characteristic that is as close as possible to have to a rectangular flow function. What does it mean? So, if I underline this keywords, that most of the most engine applications need a specific requirement, other specific fueling requirement, specific fueling characteristic that is as close as possible to a rectangular flow function. What does it mean? That means if I go back to the previous slide wherein we can see the schematic depiction. So, the moment as I said you, the natural tendency of the needle should be to remain seated over there, allowing the passage through which flow can flow should be totally blocked. So, that means the needle will always block the flow passage area, that is passage area of fuel flow. If we now allow electric current to flow through the piezo crystals will expand, and this expansion process will create a forcing on the needle will come down and again open the area or open the pathway through which fuel will be discharged into the engine cylinder. Depending on the amount of electricity we are passing, we can control this opening area. Now, so we need certain switching on time and switching off time. Switching on, switching off. Though the switching on and switching off time is less for this particular arrangement because of low inertia, because the involved mass or involved masses has low inertia for this particular arrangement, typically less than 250 microsecond. So, it is having rectangular flow, as I said, rectangular flow function. That means, if we show here time and fuel flow. So, you know that if we switch on, then it will be having, it will take less time, and then so it will take less time, then continuous flow, then again less time, and it will be again like this. So, this is rectangular flow function. So, if we start from here, so 0 time, and then it will take less time, the opening time, switching, and then it will be having almost rectangular, so almost constant flow rate for a certain period of time, then again switching off, and then like this. So, this is what is called rectangular flow function. So, that is what we have discussed. So, this particular feature, that is rectangular flow function, is achieved almost in all piezoelectric actuators. So, now finally we shall discuss about the stepper motor. As I said you that we have discussed about 3 different types of actuators. One is electric motor, stepper motor, then solenoids, and then piezoelectric actuators. So, we have discussed already solenoids and then piezoelectric actuators. Now, we will discuss about stepper motor. This is again very simple, that let me write here a few important aspects for this particular type of actuator, and then we shall discuss. So, I will quickly write a few important salient points of this particular type of actuator. What are those salient points? A stepper motor is brushless, is a brushless synchronous electric motor. Okay. So, this is number 1 important salient feature. A stepper motor converts digital passes to mechanical, or into, I should write, digital passes into mechanical shaft rotation. Okay. So, essentially a stepper motor is a brushless synchronous electric motor. So, if we have some, or if we give some input, that is digital pass, then this stepper motor will be having mechanical rotation. So, if there is a rotation, so there will be revolution. So, basically 1 revolution, 2 revolution, 3 revolution, like this. So, basically that every revolution, so each revolution of the stepper motor essentially it will rotate, so we will be having certain RPM. So, that revolution, each revolution of the stepper motor is divided into a discrete number of steps. Discrete number of steps, typically 200, right, and this is what, then the motor, the stepper motor must be sent, the stepper motor must be sent a separate pulse for each step, separate pulse, that is digital pulse, separate pulse for each step. Okay. Basically then the stepper motor that we are discussing, the stepper motor can take a single pulse at a time, or stepper motor can take only one step at a time, or single step at a time. Stepper motor can only take one step at a time, and each type of step at a time, and each step of the same size. So, if we have 200 steps, then each step of the same size, and stepper motor can take only one step at a time. That is important for this. Now, if we go back, the stepper motor, the stepper motor on receiving pulse rotates through a precise angle, right, typically 1.8 degree, So, since the stepper motor can have a precise rotation of 1.8 degree, we have, if the engine is having stepper motor, this can have precise control without any feedback. I can write the motor position can be controlled without any feedback mechanism. Right. So, if we now go back to the previous slide, so what we can see, that a stepper motor, which is again a brushless synchronous electric motor used as an actuator. So, let us discuss about the operational procedure. A stepper motor can convert digital pulses into mechanical sub rotation. So, it will rotate. So, ultimately if we have input digital pulses, stepper motor can rotate the shaft or can have mechanical rotation on by receiving digital pulse. So, as it is motor, it will be having certain revolution. The revolution, each revolution of the stepper motor is divided into discrete number of steps, which is typically 200. But each step the motor can take a single step at a time and each step of same size, right. Then if we have some digital pulses, if we have input, then it will rotate, and since this is very important characteristic, that single step it can take at a time and each step of same size, the stepper motor on receiving pulses can rotate through a precise angle of 1.8 degree. Since this the motor position can be and it is because of this only the motor position can be controlled without having any feedback mechanism, right. So, now if we go back to the previous slide, so what we can see, this is hardware, we have stator calf, output shaft, it will having some rotation. So, if we write here, it will have some rotation. So, coil B, coil A, and if we have some digital pulses, then it will have some mechanical rotation. Since mechanical rotation can be divided into discrete number of stages, we can, and that too motor has an important characteristic that it can take only one step at a time and each step of same size. We can have very the motor can rotate through a very small or precise angle, that is 1.8 degree, and it is because of this we can have motor position control without receiving any feedback mechanism. Now, the question is, since the rotation of the motor is function of proportional to the frequency of the pulses, if we have more pulses, then perhaps that rotation stepper motor, that is stepwise rotation, can be converted to continuous type rotation. So, this is what is important. So, as I said you that if the frequency of digital pulses increases, if the frequency, so essentially this motor works on the principle that the motor needs digital pulses. So, if the frequency of the digital pulse or digital pulses increases, the stepper or step movement, the name stepper is coming from this stepwise movement. So, the step movement will be the continuous movement and the rotation of the motor will be function of or directly proportional to the frequency of the pulses. So, to summarize today's class, we have discussed about actuators, why actuators are needed for the engine controls unit, and what are the different types of actuators are there for the modern engines. And then we have discussed about three important types of actuators. One is solenoid, that is most widely used because of its simple in structure and less expensive operation. Then we have discussed about piezoelectric actuator, which is very commonly used in fuel injection system. Finally, we have discussed about stepper motor, and this solenoid is an actuator wherein this electrical signal is converted to linear motion. So, with this I stop here today and we shall continue our discussion in the next class. Thank you.